Hello, this is question 13 on your June 2019 paper 1 from Edexcel. You have a curve with this equation where x is a real number that can be minus 3 or 2. P and Q are constants past this point and has two vertical asymptotas in with these equations. Explain why you can deduce that Q is 4. So Q is in the denominator and I know I have these two asymptotas. The asymptotas are going to happen when this is 0 and when this is 0. This is the one giving me 0 here, so this one is the one giving me 0 here. Yeah, so as I'm going to, you have to explain something like as, what is the name of the curve? C, no? As C has an asymptota in x equals 2, the bracket 2x minus q must be 0. And that's what we are going to do. So 2x minus q when x is 2 must be 0. Yeah? So is 2 times 2, 4 minus q equals 0, which means that q is 4. Yeah, so that's the first part. Then they say, show that p is 15. So we have p in the numerator, and the other thing that we can do is substitute this point in the equation. Yeah, so when x is 1/2, when x is 3, y is going to be 1/2. So we are going to substitute here y by 1/2. So for the second part, y is going, it's just substituting the point. So 1/2 is going to be p minus 3x, so p minus 3 times 3, p minus 9. P minus 9 in the numerator, sorry, 9, no q. And in the denominator, I know that q is 4. So when x is 3, I have 3 times 2, 6. 6 minus 4, 2. So this first bracket is 2. And the second bracket, when x is 3, is 3 times 3 plus 3, 6. So 6. This means that 1 is going to be p minus 9 divided by, I just have simplified the 2 with the 12, and 6 is going to be p minus 9, which means that p is 6 plus 9, which is 15. So that's the first part, which I think is the easy one. Then figure 4 shows that shows a sketch of part of the curve C. Region R is this one here, is bound by the curve, the x-axis, and the line with x equal 3, with equations x equal 3. So that the exact value of the area is given in this form. And we have to find A and B. So to find this area, we need to find this point. So we need to know what we are in the limits of integration. Yeah, what are we integrating between? This point is the root of this function. So we are going to find that first. And we know that p is 15 and q is 4. So the root is going to be when this function is 0. So I'm going to make my function equal to 0. So is p, well, we know that p, we say it was 15. 15 minus 15 minus what? 15 minus 3x divided by the denominator is going to be 0. That means that 15, my numerator is going to be 0, which means that 3x is 15 and x is going to be 5. So this point here is 5. So to find this area, we are going to integrate our function, yeah, this one, between 3 and 5. So we need to integrate, the area is going to be integral between 3 and 5 of 15 minus 3x, and the denominator were 2x minus 4 because q was 4, and x plus 3. That's my function. That's the thing that I have to integrate. I have product of two just binomials in the denominator, so this function is going to be very easy to integrate if we write algebraic fractions, partial fractions. Yeah, so we can write this expression as, so 15 minus 3x divided by that, but all that denominator, 2x minus 4 and x plus 3, as a divided by the first factor, 2x minus 4, plus a b divided by the second factor, x plus 3. So this is going to be a multiplied by x plus 3, just adding the algebraic fractions, and b multiplied by 2x minus 4, and all divided by the product, 2x minus 4, x plus 3. If we compare this one with this one, denominators are the same, so numerators must be the same, and that's how we are going to find a and b. So 15 minus 3x is going to be equal to x plus 3 plus b 2x minus 4. And now you can use our substitution or just equating coefficients, so it's really up to you. I'm going to use substitution. I'm going to make x equal minus 3 to cancel this one. So if I do x equals minus 3, the left hand side I have 15 minus 3 times 3, which is 9. Is 15 minus 9? No, minus 9? Plus 9, sorry. 15 plus 9, which is 24. And in the right hand side, this one is 0, and then I have minus 3 times 2 is minus 6, times minus 4 is minus 10. So minus 10b. Which means that b is minus 2.4. And then if I do this bracket 0, is x must be 4 divided by 2. So left hand side is 15 minus 6, which is 9. Is going to be this bracket when x is 2 is 5a. So 5a, which means that a is 9/5. Or if you want to divide, is 1.8. That means that we can write this integral. So if we come back to this one here, we can write that integral between 3 and 5 as this partial fraction. So a is 1.8. So we really can, I'm going to just separate both of them. So this integral is going to be 1.8. I'm going to get the number outside. 3 and 5, 1 divided by 2x minus 4 dx, plus the integral of this one, and b is minus 2.4. So it's going to be minus instead of plus. 2.4, I can get it outside the integral. 3 and 5, 1 divided by x plus 3 dx. Yeah, so I'm just writing this expression here as this one, where a is 1.8 and b is minus 2.4, and I'm just integrating those expressions. Yeah, you can get these numbers outside or you can leave them here, it really doesn't matter. So I have 1.8, and this one I have a function, and in the numerator I have the derivative, just missing the 2. So what I'm going to do is to divide by 2. So I'm going to write 1/2 ln 2x minus 4, because when I derivate ln of this function, I'm going to have 2 divided by this function again, and the 2 is going to cancel with this one. And this is between 3 and 5. And then the second one is 2.4, and in this case, the numerator is the derivative of the denominator, so I can write this. Now I substitute, and I have 1.8. When I substitute by 5, I have 2 times 5, 10, minus 4, 6. So I have, well, I can divide 1.8 by these two. So I'm going to do that. So I have 0.9. And when I substitute by 5, I have 10 minus 4, 6. So ln 6. Minus when I substitute the 3, I have 6 minus 4, 2. So ln 2. And I'm going to do the same with the other one. So minus 2.4. When I substitute the 5, I have 5 plus 3, 8. So ln 8. Minus, when I substitute the 3, 3 plus 3, 9. So ln 9. Sorry, 9, no. 6. I'm adding, not multiplying, so 6. And we need to write the expression as ln2 and ln3. And all these numbers can be written in terms of ln2 and ln3. So I have ln2 here. I can have ln2 here because I know that 8 is 2 to the power of 3. So this is ln 8 is the same than this expression here, which is 3 times, just using the properties of the logs, times ln 2, and the same with ln 6. So ln 6, I'm going to put them together first, so because I have 2 ln 6, so let me put them together. I have 0.9 ln 6 plus 2.4 ln 6 is 3.3 ln 6, no? 3.3 ln 6. And then I have minus 0.9 ln 2. And then here I have minus 2.4 times 3. So minus 7.2 ln 2. Yeah. And now I can write the ln 6. So now in this next step as ln 2 times 3, which is ln 2 plus ln 3. Yeah? So this is going to be 3.3 ln 2 plus 3.3 ln 3, just substituting this here. Yeah, so the 3.3 is going to multiply this one and this one, and then minus this bit here. So minus 0.9 ln 2 minus 7.2 ln 2. And now I can put all together. So I have ln 3, just this one, so 3.3 ln 3. And then I have 3.3 minus 0.9 minus 7.2, which is minus 4.8 ln 2. And then I have it. So this is my expression. I'm going to write just a and b. So a is the coefficient of ln 2. A is the coefficient of ln 2. So a is minus 4.8. And b is the coefficient of ln 3. So b is 3.3. So I would recommend you, even if this one is the expression, that at the end you write a line giving the coefficients that they are asking you for. Yeah, because they say where a and b are rational constants to be found. They are rational constants. You can write them this way, or you could write them as fraction, but it's the same. So minus, it could be minus 48 divided by 10 and 33 divided by 10, but you can leave them like this. Yeah, and that's all with this example.